Good day, grade 10s and grade 11s. This is Elton from Maths and Science series. Today we'll be doing quantitative aspects of chemical change, physical sciences, chemistry. So, a quantitative aspect of chemical change topic, it's a very broad topic, or a long topic if I can put it that way, but today we'll be focusing on finding the empirical formula and the molecular formula. So before we continue with this topic, I would like to thank those who subscribe to the channel and those who are still subscribing even now. So do not forget to subscribe. Do not forget to, and as you subscribe or as you are subscribing, please do not forget to hit on the notification bell so that you can be notified when we upload new videos. And please comment, share and like the videos. Before we can get to the empirical formula, or on how to determine the empirical formula and the molecular formula, let's just discuss this. We have something known as a mole. So it is very important that you know how to define the term mole. So this is the formula for calculating the number of moles. The number of moles. So it is very important that you know this formula, because as we are going to find or determine the empirical formula and the molecular formula, so it is very important that you know how to use this formula. So we have N here. This is the number of moles in mole. These are the SI units for moles. Now we have that small letter M, it is mass in grams. Now we have this one here, the capital letter M, it is known as the molar mass in grams per mole. So it is very important, guys, that you know how to use this formula. Actually, this formula, you can use it to calculate the number of moles or to calculate the mass if you are given the number of moles. So it is very important. This is one of the steps, or you use this step as the first step for determining the number of moles. So it is very important. So they can give you the mass of that particular element in kg, but you know that the SI unit for mass in chemistry or in paper 2 physical sciences, they are the physical or the SI units, we know them as grams, but they can give you kilograms, so you need to know how to convert them. Now let's discuss about empirical formula and the molecular formula. So we'll start by the empirical formula, because you cannot get the molecular formula if you don't know how to determine the empirical formula. So an empirical formula, we say that it is the simplest relationship in which atoms combine. So empirical formula, the simplest relationship in which atoms combine. When you talk about atoms, we are talking about all the elements that are found on the periodic table. Now on the periodic table we have elements, or everything that is written on the periodic table. Those things, they are known as elements. For example, we have hydrogen, magnesium, zinc, we have fluorine, we have argon. So everything that is written on the periodic table, they are known as elements. But now, if I can take a hydrogen and combine it with other element on the periodic table, now it means that, let me say, I combine hydrogen with oxygen. So these are two different elements. We have element H and we have element O. It means that this is no longer an element, but it is what? It is known as a compound. Why? Because I've combined two different elements, right? I can combine carbon with oxygen. So this, it's an element and this an element. But as I've combined these elements, now I have what? CO2, right? Now as I have CO2, this CO2 or carbon dioxide, it is known as a compound. So in other words, if I can take all the elements that are written on the periodic table, then I combine them with different or with other different elements, I won't have, or I won't call that particular thing that has resulted as I combined the elements. Now we'll have something known as the compound, because it is the combination of two or more different elements combined together in a fixed ratio. So that's the definition of a compound. I don't know if you are following. So I'm starting with this because it is very important. It is very important. I will remind you, I will show you where you must, or I will just remind you about the importance of these two terms, element and the compound. Now, there are steps for you guys to know for finding or determining the empirical formula. Just an easy thing, but make sure that you know this step. Okay, I'll just the first step, you find the number of moles. This is the first step. Find the number of moles. Now you'll be given a compound. Now after giving that compound, then you'll be asked to find or to determine the empirical formula for that compound. Then what you will do, you have to make sure that you scatter or you separate that compound. Then you look for the number of moles for each of each of the elements that formed that particular compound they are asking you to find the empirical formula for. Then you do what? Let me say you are given let me say it's HCN, hydrogen cyanide. Let me say that we are given this. So you find the number of moles of hydrogen, you find the number of moles of carbon, you find the number of moles of nitrogen. Knowing that everything you are provided, they provided you with everything or all the data you are given in your statement. So you find the number of moles for hydrogen, number of moles for carbon, number of moles for nitrogen. Then after finding the number of moles, you compare the number of moles of hydrogen, the number of moles of carbon, and the number of moles of nitrogen. Then you divide with the least or the smaller number of moles. I don't know if you understand that. If for example, let me say I have the number of moles or the smallest number of moles, I have it maybe for hydrogen. Then I take that smaller number of moles, I divide all the number of moles that I got when I calculated for hydrogen, carbon and nitrogen. Then after dividing all the number of moles with the smaller number of moles, now that is when you are closer for finding or determining the empirical formula. But now let me just stop just explaining this. Let's do what? Let's do a small a first example. Then after that example, you will see what I'm just trying to explain here. But it's very important that you know how to define the term empirical formula, the simplest relationship in which atoms combine. So in other words, the empirical formula in simplicity is just combining the atoms of that particular compound which they will ask you to find the empirical formula for. So the first step for you to know, you find or determine the empirical of the step for determining or finding the empirical formula. The first step is that you need to find the number of moles using that formula, which says that N equal to mass over molar mass. Here is our example, or the first example for finding the empirical formula. A chlorinated hydrocarbon was analyzed and found to consist of 24.24% carbon, 4.04% hydrogen, and 71.72% chlorine. Then they say find the empirical formula. But the first step that I told you about is to find the number of moles. Now you write all your formulas knowing it. It is very important that you must know it by head. Now, how am I going to use that formula since it consists of grams, but here in the statement I am given percentages? The first thing which you must know, you write that 24.24, since it is symbolized by that percentage symbol, you replace that percentage symbol by putting the gram. So 24.24% carbon. Now it is 24.24 grams carbon. Now you are given 4.04% hydrogen. You remove that percentage symbol by placing or putting the gram, 4.04 gram hydrogen, and 71.72 gram chlorine. Now we are happy because we are having our masses: 24.24 gram carbon, 4.04 gram hydrogen, and 71.72 gram chlorine. Now, what you must know, the first step, you must bear it in mind, or you must know it all the time. So, you find the number of moles for carbon, you find the number of moles for hydrogen, you find the number of moles for chlorine. Now, let us find or determine the number of moles for carbon. It is 24.24 over, what is the molar mass for carbon? It is 12, right? Now when you use your calculator, here you are going to get 2.02 mole. Use that on your calculator. Now we found the number of moles for carbon. Now we find, or we look for the number of moles again for hydrogen, 4.04 over the molar mass for hydrogen. Actually, the molar mass, it is the relative atomic mass on the periodic table. So carbon on the periodic table, it is written as C. Now here I don't know if it is 6 and 12, but something like that. Now we take the bigger number, that's the relative atomic mass. We put it as a molar mass. Now 4.04 divided by the molar mass for hydrogen, which is 1. We are having 4.04 mole. Remember putting the SI units for number of moles. We come here, number of moles for chlorine. Now mass, it is 7.72 over the molar mass for chlorine, which is 35.5. Now you punch that on your calculator, you will get 2.02 mole, right? It is very important that you show us the SI units. Now the first step, we've covered the first step by calculating the number of moles for carbon, hydrogen, and chlorine. Remember, we'll be given percentages. Now you do not multiply or divide by whatever to convert percentage to grams. You just remove that percentage, that percentage symbol or sign, then you replace it with the gram. Now find the number of moles for carbon, hydrogen, and chlorine. Now we check, or we compare the number of moles that we got. we are looking, or we are checking the smaller number of moles. Now, as we can see that this is the smaller number of moles, we need to take it and divide all the number of moles which we've got. Then after that, you will see what is that we're going to do. But first thing first is for you to do what, to determine the number of moles. And after finding the number of moles, you check if you have the small number of moles in all the number of moles that you have calculated or you have determined. Now 2.02, it is the smaller or smallest number of moles. Now I take this number of moles, I divide the other number of moles by the smallest one. Now I say 2.02 divided by 2.02, I get 1. Now here 4.04 over 2.02. Use your calculator, you will get 2. You come here, 2.02 divided by 2.02, you're getting 1. Now the next step, you just draw a small table like this. Since you are given 3 elements, you are given element carbon, you are given element hydrogen, and you are given element chlorine. Now after you have divided the number of moles that you have calculated with the smaller number of moles, for chlorine you got 1, right? Then for hydrogen you got 2. Then for chlorine you got 1. Then the empirical formula is, you got after you have divided with the smaller number of moles, in carbon you got 1, so you put 1 there. In hydrogen you got 2, you put 2 there. In chlorine you got 1, you put 1 there. Even if you don't put them, because you know that actually this number here, it's a subscript showing us how many times is the carbon element repeated. So here it means that we have 1 carbon, we have 2 hydrogen atoms, we have 1 chlorine atom. Remember when you started this lesson, I explained or I showed you the difference between elements and compounds, right? Now here we used compounds. We calculated the number of moles for element, and that element. Then after that, by combining those elements, we got the empirical formula, which is CH2Cl. This is what a compound. So that is why I say that the empirical formula is actually the simplest relationship in which atoms combine. So this, whatever that I've done here, actually we are showing the teacher or whoever is going to mark your paper that for us to have that empirical formula, we must have carbon atoms combined with hydrogen atoms combined with chlorine atoms for us to get the empirical formula C1H2Cl. But the most important thing, or the most important thing for you to know, and the first thing for you to know, you calculate the number of moles for each element that you are given on the statement there. Now you'll be given percentages. What you must do, you convert those percentages to grams, but you are only just removing the percentage, then you put what, the gram. It's not that you're going to multiply or dividing so that you can convert percentages to grams. No. So this is the first example. Now let's go and do the second example so that you can understand this thing of finding the empirical formula. And after finding the empirical formula, we will find the molecular formula. So here, sorry, it was not visible. The empirical formula is C1H2Cl1. So that's our empirical formula. Sorry for the inconvenience. Here is our second example. Vinegar, which is used in our homes, is a dilute form of acetic acid. A sample of acetic acid has the following composition: 39.9% carbon, 6.7% hydrogen, and 53.4% oxygen. Find the empirical formula for acetic acid. The first thing you need to do, you need to convert the percentages to the grams. 39.9 gram carbon. You put the C there, 6.7 gram hydrogen, and 53.4 gram oxygen. Then you check the first step on the notes that I gave you. Now you find the number of moles for carbon, the number of moles for hydrogen, sorry, it's actually M, number of moles for oxygen. Now the number of moles here, we have 39.9 over molar mass for carbon, which is it's 12. Now the number of moles hydrogen, we have hydrogen 6.7 over 1. Here 53.4 gram over the molar mass for oxygen, which is 16. Then you just use your calculator, say 39.9 divided by 12. We have 3.325. Number of moles 3.325 mole. Now here we have 6.7 moles since it is divided by 1. The number of moles here is saying 53.4 divided by 16. We are having 3.3375 mole. Now remember, the next step after you have determined the number of moles for all the elements which you are given, you compare all the number of moles that you have got or that you have determined. You check the smaller number of moles, then you divide all the number of moles by that small number of moles, or that smaller number of moles that you see as you are comparing the number of moles which you have determined. Now this one, it is the smallest number of moles. Now what you do, you say 3.325, you divide it by 3.2, divided by 3.325, you'll get 1. Here you take that one, which is 6.7, you divide by the smallest number of mole, or the smaller number of mole, which is 3.325. You just write that on your calculator. 6.7 divided by 3.325, you get 2. You get 2 here. Let me just write it like this. 2 for the pattern to continue. Now 3.3375 divided by 3.325. Now you divide that 3.3375 divided by 3.325. We get 1. Now you just draw that smaller table. Since you are given 3 elements, the first element here, it's carbon. The second one, it's hydrogen. Then the third one, it's oxygen. Now after dividing all the number of moles by the smaller number of moles, or the least one, in carbon we got 1. So that's the subscript for carbon. In hydrogen we got 2. That's the subscript for hydrogen. In oxygen we got 1. That's the subscript for oxygen. Therefore the empirical formula is C, we got 1, H we got 2, and O we got 1. So this, it is the empirical formula for acetic acid. Or you can just say it's C1, it's CH2O. So I'm just showing you that all the subscripts or all the answers that you are getting here, we know them, or they are known as subscripts. I hope you understand this. So the first thing you do it, you convert or you remove that percentage symbol by replacing it with the grams. Then you find the number of moles for each of or for every element which you are given. Now we use the elements to show how are they combining, so that we can get the empirical formula, since we say that the empirical formula, the simplest relationship in which atoms combine. So this relationship, it's showed after, or we've shown it after finding the empirical formula, because we showed how is carbon combined with hydrogen and oxygen to form CH2O, or the empirical formula for acetic acid, which is CH2O or C1H2O1. So I hope you understand this. So do not forget, again guys, please do not forget to like, share and comment, and to subscribe too. Let's do the third example, then we do the molecular formula. A laboratory analysis of a compound shows that it has the following chemical composition: carbon 76%, hydrogen 12.5%, oxygen 11.5%. Now determine the empirical formula for the compound. Now the most important thing, or the first thing for you to do, you need to convert, or you need to remove that percentage symbol by replacing it with what? The gram. Now here we have 12.5 gram hydrogen, the oxygen, actually 11.5 gram oxygen. Then you find the number of moles for carbon, find the number of moles for hydrogen, find the number of moles for oxygen. Now here the number of moles, 76 gram over 12, which is the molar mass for carbon. Then here it's number of moles, 12.5 gram over 1. Then here number of moles, 11.5 gram over 16. Then you use your calculator, 76 over 12. You're having 6.33 mole. Then here obviously you are having 12.5 mole. Then there 11.5 over 16, you are having 0.72 mole. Now you compare after dividing, or after determining the number of moles, you compare the smallest answer in these answers which we've got. Now we got 0.72 as the smaller number, or the smaller answer, or smaller number of moles. We use that one to divide the number of moles which we've found. Now we'll say 6.33 divided by 0.72, 12.5 divided by 0.72, then 0.72 divided by 0.72. We got 1 there. Then here just use your calculator, saying 12.5 divided by 0.72, you will get 17. Then remember your answers, you must not put them in decimal form. Now 6.33 divided by 0.72, then our answer here is 9. Therefore, you show that table. Since you are given three elements, the first one is carbon, the second one is hydrogen, then the third one is oxygen. After dividing by the smaller number or the smaller answer, for carbon you got 6. You got 9. For hydrogen you got 17. And for oxygen you got 1. Therefore, the empirical formula for this compound is C9H17 and O1. So this is the empirical formula. So the first thing which you must know, guys, is that you'll be given percentages. Sometimes they can give you grams, but if you are given percentages, make sure that you remove that percentage symbol by replacing it with the gram or the mass or the SI unit for mass. Then you determine the number of moles for each of the elements which you are given on the statement. I don't know if now you remember or you see the importance of knowing or differentiating between an element and the compound. Now we say that the empirical formula is the simplest relationship in which atoms combine. Actually, we are showing the teacher here, or we are showing whoever who's going to mark our scripts or your script, that we showed how is carbon contributing with hydrogen contributing and oxygen contributing to form the compound known as C9H17 and O1, which is the empirical formula. So that's the simplest relationship in which these elements are combining to form that compound, which is C9H17 and O1. The chemical composition of a particular compound is 11.79% carbon, 69.57% chlorine, 18.64% fluorine. Determine the empirical formula of the compound. So do this one, guys, on yourselves. Then after that, you leave your answer on the comment platform. Now we are moving. Then we are doing molecular formula. The molecular formula, actually the empirical formula and the molecular formula, there is a relationship that is existing between these two terms or these two words, if I can put it like that. Now you will see why we started by dealing or discussing the empirical formula. So for you to find the molecular formula, you need to know how to find the empirical formula. So do not forget to leave your answer for this activity, just to check if you understood what I was doing there. So after you got your answer, just send it on the comment platform. Now let's discuss or let's talk about molecular formula, and after that, after discussing the molecular formula, we'll be done with our lesson. Then we'll continue or we'll upload another part that is under quantitative aspects of chemical change, which will be for grade 11s, which is grade 11 and grade 12, if I can put like that, on how to determine or to check if a reaction is limiting or it is an excess reaction, and we do other things which are under the quantitative aspects of chemical change. So now let's focus on the molecular formula that works hand in hand with the empirical formula. Molecular formula. I told you guys that molecular formula and empirical formula, they actually have a closer relationship, because you cannot find the molecular formula of whatever compound or of whatever they can ask you to find the empirical formula for or the molecular formula for. before you can find the empirical formula. So in other words, I'm saying that you cannot find the molecular formula if you don't know how to find or to determine the empirical formula. So now this is our main task to do, but we understand that we cannot find the molecular formula if we don't know how to find the empirical formula. So before we can tackle or before we can determine or find the molecular formula, let us first find or determine the empirical formula. Now, given 39.9% carbon, 6.7% hydrogen, and 53.4% oxygen, then they say determine the empirical formula. You know that you need to do it, you need to say 39.9 gram carbon, 6.7 gram hydrogen, and 53.4 gram oxygen, right? Now you find the number of moles for carbon, number of moles for hydrogen, and the number of moles for oxygen. Therefore, where does that small letter m or the upper one, the numerator, we put 39.9 over the molar mass for carbon from the periodic table. We know that it is 12, right? Here we have 6.7 over 1. Here we have n equal to 53.4 over 16. Then let us find our answers. Use your calculator. 39.9 over 12, you get 3.325 mole. Then here you get 6.7 mole. Then here it's 53.4 divided by 16. You're going to get 3.3375 mole. Now these are our answers here, or the number of moles. We got 3.325, we got 6.7 mole, we got 3.3375. You know that after you have calculated the number of moles, you check the number of moles of carbon and of hydrogen and of oxygen. You check the smaller number of moles, then you divide all your answers by that smaller number of moles. Then the smaller number here is the first one for carbon, which is 3.325. You divide it by itself, you will get 1. Then here 6.7 over 3.325. Remember your answers, you must not write them or you must not make them to be in a decimal form. So here we have 2 and 3.3375 divided by 3.325. Then we have 3.3375 over 3.325. We get 1. Now these are subscripts. Now since we have 3 elements that we are dealing with, we have carbon, we have hydrogen, we have oxygen. Then for carbon we got 1, right? Then for hydrogen we got 2. Then for oxygen we got 1. Then the empirical formula is C1H2O1. So this is our empirical formula. So understand this, we got our empirical formula, right? Now we are asked to find the molecular formula of acetic acid. So in other words, this is acetic acid, or this is the empirical formula. Therefore, we are asked to find the molecular formula of acetic acid if the molar mass of acetic acid is 60 gram per mole. Now, what you must understand or what you must know is that since the second question is asking you guys to do it to find the molecular formula of acetic acid, in other words, they gave you the molar mass for acetic acid, right? Now here we have what we are having the empirical formula. So what you must know is that you must find the the molar mass for the empirical formula, since they gave you the molar mass for the molecular formula. I don't know if you understand that. Now you are asked to find the molecular formula. Now, how are you going to use this 60 in order for you to find the molecular formula? As I said that before you can find the molecular formula, you must know how to find the empirical formula. We got our empirical formula, right? Therefore, now the statement is telling us to find the molecular formula of acetic acid if the molar mass of acetic acid is 60 gram per mole. Now, they gave us the molar mass of the molecular formula. Now you need to find the molar mass of the empirical formula. After finding the molar mass of the empirical formula, you take the molar mass of the molecular formula, you divide it by the molar mass of the empirical formula. So this is what I am saying. Molar mass for the empirical formula, which is CH2O. You know that for you to find the molar mass, you use your periodic table. What is the relative atomic mass for carbon? It is 12. The relative atomic mass for hydrogen, here we have H2. This subscript tells us that we need to multiply the relative atomic mass of hydrogen by 2. So we'll say 2 times the relative atomic mass of hydrogen, it's 1, plus the relative atomic mass for oxygen, it's 16. Then you use your calculator. You just say 12 plus 2 plus 16. You have 30 grams per mole. Now you are done. Why? Because you found the molar mass for the empirical formula, since you are given the molar mass for the molecular formula or of the molecular formula. Therefore, now you will take the bigger molecular mass, molar mass, you divide it by the smaller molar mass. In other words, you take the molar mass for the molecular formula, you divide it by the molar mass of the empirical formula. So it's 60 divided by 8. You get 2, right? In other words, since you got this 2, you need to multiply the subscripts of the empirical formula by that 2. I don't know if you understand that. So now, since the empirical formula we had C1, it means that now we will have C1, we'll say 1 times 2, right? Then H2 times that 2 again, times O1 times 2. We'll end up having C2, H4, and O2. So this is what the molecular formula. I don't know if you're understanding this, but the most important thing first, for you to find the molecular formula, you have to find the empirical formula first. And after that, on that statement of you finding the molecular formula, they will give you the molar mass of the molecular formula. Now you have to find the molar mass of the empirical formula. Then after that, you take the molar mass of the molecular formula, you divide it by the molar mass of the empirical formula. Now we got 2. Therefore, this 2 is going to multiply on the subscripts of the empirical formula. Therefore, this is our molecular formula. Now let's check, or let's do the second one for finding the molecular formula. So please just pause the video, then you do it on yourself, then you will just continue the video to see if you are correct or incorrect. But I trust you guys, you will get this correct. And don't forget to just comment on the platform, on the comment platform. Given the empirical formula as C4H4O, if the molar mass of methyl benzoate, so this is methyl benzoate, is 136 gram per mole, what is its molecular formula? Remember, you will always be given the molar mass of the molecular formula, right? Now you need to find the molar mass of the empirical formula. Then you take the molar mass of the molecular formula, we divide it by the molar mass of the empirical formula. Then you get your answer. Then you take that answer, you multiply it with the subscripts of the empirical formula. And after multiplying it with the subscripts of the empirical formula, you got your molecular formula. Now we find the molar mass for methyl benzoate equal to the relative atomic mass of carbon is 12. Therefore, the subscript for C there we have 4. Then we'll say 4 times the relative atomic mass of carbon 12 plus we have 4 there, 4 times the relative atomic mass of hydrogen is 1 plus 16. Since we have the subscript for oxygen or of oxygen is 60 is 1. Therefore 1 times 16 we have 1. Therefore just use your calculator. 4 times 12 plus 4 plus 16, which is 68 gram per mole. Remember, we are looking for the molar mass. Therefore, grams per mole is the SI unit for the molar mass. Now we are done. We just take the molar mass of, we are done looking or finding the molar mass of the empirical formula. Therefore, we have to take the molar mass of the molecular formula, we divide it by the molar mass of the empirical formula. 136 gram per mole over 68 gram per mole. Or if you like, you can just write it like this. But what you need to know is this will cancel that. Then 136 divided by 68. 136 divided by 68. You will get 2. In other words, these 2, we're going to take it and multiply the subscripts of the empirical formula, then we get our molecular formula. So C4 times that 2, H4 times that 2, O, since here we have nothing, the subscript is 1 times 2. Therefore, the molecular formula is C8H8O2. So this is our molecular formula. Yes, so this is our molecular formula. The most important thing before you can find the molecular formula, you need to know that you must have the empirical formula. Now, on that question of finding the molecular formula, they will give you the molar mass for the molecular formula. What you have to do, you have to find the molar mass of the empirical formula. Then after that, you take the molar mass of the molecular formula, you divide it by the molar mass of the empirical formula, then you get your answer. Now after getting your answer, make sure that that answer of yours it's not in decimal form. You take it, you multiply it by, or you multiply it with those subscripts of the empirical formula, then you get the molecular formula.